Today we'll be building the iconic snake game that most of you know from your childhood. In this snake game you have a snake that goes around. It can only go in one direction, cannot turn in 160 angles. It has to pick up the fruit to grow, and it's bound to a playground area where if it bumps into, the game is over. And your goal is to grow your snake as large as possible. And also if you bump into yourself with your snake, then the game is over. That's what makes it interesting. I hope you're ready. Let's get started. Starting off, we have our basic three files. One of them is our index.html, where we have our CSS linked and our script.js linked, as well as an age one. In our style.css, this won't change. These are just some basic settings, nothing too crazy about it. And our script.js is completely empty. In our HTML, we'll be working with a canvas element, so let's create one. And also, let's give it an ID, playground. Okay, now we can tick off the HTML and the CSS, because all this time we'll be working in our script.js. In our script.js, I'll copy over some basic settings and explain afterwards. Here we have a bunch of global variables. One of them is the playground. We'll be getting the playground and storing it globally here. We define the amount of rows and columns we want for our playground, and the unit size, meaning how much space should one cell take up. We're also defining a context. This will be needed for our canvas element. We are defining a movement X and movement Y values. These will be for the time when we are moving the snake. The snake cannot move only in one direction, and if it changes, the others will be set back to 0, which means they are not moving on that axis. We are defining a little bit of speed here with the moves per sec. We are also defining the player body, which will be an array that will hold arrays as of positions. There will be a boolean that will check if the game is over or not, and there will be an interval that we'll be using because we have to store it, and then later when the game is over we'll be having to clear it. And here we are using some SVG icons you'll be able to access from the source code or from our GitHub repository. We are creating images dynamically from JavaScript, so the snake head image will be a new image and the source will be the /snake.svg. This is a relative path. It is the fruit, the snake, and the body.svg, and we're doing the same for the fruit and the snake body. Now, setting some default values, we have to go into our window.onload event. So after our browser successfully loaded, we are going to assign this a function, and inside this function we are going to set the playground to be equal to the document.getElementById, and then simply the playground, the ID that we've given it. We are going to set the playground's width to be equal to the columns times the unit size, and we'll be doing the same for the height, except here the rows times the unit size. We'll be setting the context to be equal to the playground.getContext. This is a built-in canvas function. What getContext does is that it receives a parameter. This time it will receive a 2D that will set the canvas to render 2D elements when we are drawing on it. I've zoomed in a little if it's more clear this way. Next we'll be having to define the default positions of the player and the foods. So let's create a variable called player x, and this will be equal to the math.floor. We are flooring down the value, and we're creating a random value with the math.random, which prepares a random value between 0 and 1, and we are multiplying it by 10, and that's still not enough. We are also multiplying it by the unit size, so it's always in sync with our playground. Let's just copy this over one more time. This will be the player y this time. It's the same value. Next we'll create the food x and the food y values. By default these will be empty, and we'll create a function for spawning the food. We need this as a function because we'll be continuously calling the spawn food function whenever it's picked up. We'll set the food x to be equal to what we set the player x to be, so it's a random value. And we'll also do the same for the food y. Next, we'll come back to our onload function, and after the context is given and the browser is loaded, we'll say spawn food. So we're calling the function initially. But that's still not enough because we haven't even touched our canvas, and the canvas will be responsible for drawing things out. So we'll create a function called draw. First of all, let's set a color for our context, and this context is going to be set by the fill style value, and set a color for this fill style between quotation signs I'll give a hexadecimal value. Next we'll make the draw function render the rect. So context.peerRect. First the x and the y values, which will be set to 0 in our case, and then the width and height, which will be set to playground.width and playground.height. Now just so we can see what's happening, I'd like to set an interval for the draw function. So we'll set the interval, because we'll be storing it in a separate variable, to be equal to setInterval. We are calling the draw function, and we'll be calling this every 1 second divided by the moves per sec. It already drawed out the canvas, and it's continuously drawing every 1 second or less than 1 second depending on the moves per sec value. Now let's handle drawing the image. We'll be saying context.drawImage. And here, since we've already created an image, as you can see, the first parameter is a canvas image source. We'll be giving here the fruit image, and then we'll give x and y coordinates for its position, which will be food x and food y. Next, we'll be giving a unit size. And this time, since the SVG is a little smaller, I decided to multiply it by 1.2. And for the height as well, unit size times 1.2. So this is just the width and height. When you are drawing an image, you give the image x and y coordinates and width and height. It's really simple. I'll be copying this over, and let's do the same for the player. So just copy this over. We are here calling the snake head image to be drawn instead with the player x and player y coordinates, and the unit size, which is the same because it's defined on the top level. Now before we are drawing out anything, let's check, because this is going to happen every less than 1 second, whether the player x is equal to the food x and the player y is equal to the food y. So basically, are we colliding with the food? Because if we are, then we are going to pick it up and push a new player body element. So player body.push, and here, as I said, we are going to give the positions. So this will be the food x and the food y positions in form of an array. And we will be calling the spawn food function again. Now before we move any further with how the body is rendered, we'll be moving on to creating a new function and handling the movement of the head. And this new function will be called changeDir. As of change direction, it will receive an event object. And first of all, I'm going to console.logout the event.code. This event.code is going to be the key that we're currently pressing, but before that, we have to come back to where we started all initially. And before we spawn in any foods, we'll be giving here a document.addEventListener, and we are looking for the key down event, and we are calling the change direction function whenever a key is pressed. Let's see how this is working in practice. If I open up the console and drag this out, you can see I've just pressed F12, but I could also press the arrow down, arrow left, arrow right, arrow up. We'll be checking against these values. Actually, if I dog this to the bottom, you might be able to see it better. There we go. It even tracks the other values, but we'll be working with the arrows simply. Here we'll be having a bunch of if statements. For example, if e.code is equal to the arrow up and the movement y is not equal to the 1, which means it's not equal to the opposite that we'll be setting it to, because the snake cannot just turn around in 160 degrees and go the opposite way, because then it would be colliding with its own body. So if these conditions are met, we'll be setting the movement y to be -1, and we'll also be setting the movement x to be 0, because the snake can only move in one direction. We'll be copying these over, and this time I'll be checking against the arrow right, and here change the movement y to be movement x instead. Copy these values over as well. But here we'll be setting the movement y to be 0, because we are starting to move vertically, and we'll be setting the movement x to be 1. Let's copy this over once again. This time we'll be checking against the arrow left, and here what I've missed in the top is that it's on the arrow right it has to be -1, and here it's only 1. So these are opposite values. We'll be setting the movement y to 0, that's correct, and except we'll be setting the movement x to -1, so it goes in the left direction. And let's copy over the arrow right value once more, and this time I'll be checking against the arrow up. We'll be setting the movement y to be equal to -1. Sorry, not the arrow up, we are checking against the arrow down. We'll be setting the movement y to be equal to 1 and the movement x to be equal to 0. The reason we are working with 0, 1 and -1 values is because we are actually calculating here, and by setting it to a negative number, we can make it move left or down, and by setting it to a positive number, we are making it move up or right. Now after we've drawn our image, we'll be moving the player. Player x will be set plus equals to the movement x times the unit size, and we'll be copying this over and we'll be doing the same for the y coordinates. So now we can move the player around, it's just that it goes completely out of our canvas. So to stop that from happening, at the end of our draw function we'll be setting an if statement, and this if statement will say if the player x is less than 0 or the player y is less than 0, that means something went wrong. Or if we are out of bounds, that means we are off the playground on the y or the x-axis, then game over will be set to true. And to handle the game over, we'll be setting yet again an if statement. If the game is over, then we're clearing the interval first of all, because otherwise it would continuously tick. We alert to game over and we'll say location.reload, which means we are forcing the browser to refresh. If I test this out now, first of all I go over the fruit, that's working, our spawn fruit is working nicely, and the game is over whenever I bump into a wall. Now let's handle drawing out the body of our snake. So we'll be writing a for loop here, let I will be equal to 0, and we'll be going until we reach the player body's length, and we'll be incrementing the I. And here we'll simply be saying context.draw image. We are drawing the snake body, which is the image, the SVG that we've created initially. We are also going with the player body, and the player body's I. So for example, this will be 0, then 1, incrementing all the way through the player body position array, and we are yet again indexing it. We'll be looking for its first value, which is the x value. We'll be copying this over. And the next value that we are looking for is the y value, so I just change this to be 1. And then I'll also be saying unit size and unit size for better sizing. And we are done with the drawing out of the image. So if I go over one of these, you can see that it gets spawned, the image is there. It's just that it's going all over the place and we need to handle that as well. Now let's handle moving and connecting the player body images. So we'll be creating a for loop. This will be for continuously moving the player body. We'll be setting I to be equal to the player body dot length -1. That means we'll be going backwards in our array or in our loop. And we'll be going until I is greater than 0. And we'll be saying I -. We'll be setting the player body's I indexed value to be equal to the player body I -1 index value. That means we are constantly pushing the last element to be equal to the last -1 element. That means we are basically just moving and pushing the body parts around. And we'll be setting an if statement. If player body dot length is true, that means if we do have a body, then we'll be setting the player body 0 index element to be equal to the player x and the player y. Just make sure to wrap these in brackets. So now we have our body working. As you can see, I can pick up these little elements if I was a little more precise. But we still need to handle the scenario where I go and bump into myself. And to handle that scenario, we'll be going after the collision check. So we'll be writing another check here, but with a for loop. Let I equal 0. We are going over the player body. And we're incrementing the I value. And we'll be writing a check if player x equals player body I element, and the index is again the 0 element for the x value, and if we are colliding on the player y-axis with the player body's currently indexed element and the first, so it's actually the y coordinate, that means game over will be set to true. And we are done with our snake game. If you try it out now, we should be good to go and it should be working. So I hope you enjoyed it. The source code will be down in the description, and you'll be also able to find the GitHub repository if you prefer that. If you found value in this video and would like to see more, please consider giving us a like, maybe even subscribe. And other than that, I hope to see you in the next one. God bless.